Okay, so we are going to use properties of angles, triangles, and the Pythagorean Theorem in this section. Alright, so it's pretty important that you know that a straight line, and by straight line I mean something that looks a lot like this guy right here, is from one side all the way over to the other side 180 degrees. So think about that. If I were to go all the way around the other way, you'd have another 180 degrees, which would be a circle. So therefore circles, which we're not really working with in this section, but circles are 360 degrees and lines are 180 degrees. Alright, so what you get here, this angle A, it can sometimes be written like this, angle A. What am I doing? There we go. Is made up of two rays, and two rays look like this. So here's a ray, and then here's a ray. They have the same starting point, and this right here is called the vertex. Now the plural form of vertex, so if you're talking about more than one vertex, is vertices. Okay, so the plural form, like I just said, is vertices. That's multiple vertexes. Vertexes, by the way, is not really a word. So vertex or vertices. Alright, so we measure angles in degrees. That's what this little bitty circle is up above. You guys have seen that before whenever we talk about temperature. It is different than temperature. So this is a distance measure. So from here to here is 60 degrees. From here to here is 120 degrees. Okay? So if two angles add up to be, or have a sum of 180 degrees, they are said to be supplementary. Alright, if two angles have a sum of 90 degrees, they are said to be complementary. Alright, this page right here just kind of sums it up. So it says here, if angle A and angle B are supplementary, then their angle measures add up to be 180 degrees. If the sum of the measure of two angles is 90 degrees, then they are complementary. Here's how I remember that. So C comes before S in the dictionary. So 90 comes before 180. That's how I remember this. Alright, on this problem right here it says an angle measures 40 degrees. Find its supplement and its complement. So on part A, we are going to find its supplement. So I know that whatever that angle measure is, we're going to call it x for now, plus 40 equals 180. So subtracting 40, I get that my angle measure is 140 degrees. That's part A. That's its supplement. So its complement, this time it equals 90. So I'm going to subtract 40 from both sides. I get that x is equal to 50 degrees. So that's part B. That's its complement. Alright, so on this one, two angles are supplementary. So that means they add up to be 180. It says the larger angle is 30 degrees more than the smaller angle. So I'm going to let x equal my smaller angle, and I'm going to let x plus 30 from right there equal my larger angle. Okay, so I know that the sum of these guys is 180. So x plus 30 equals 180. So now I'm going to combine my like terms. I'm going to get my constant terms on the same side. And I'm going to divide by 2. So I get that x is equal to 75 degrees. That's my smaller angle. Remember, that's what we said x was. Now to get my larger angle, I'm going to put 75 in for x right there. So 75 plus 30 equals 105. So my two angles that I'm looking for are 75 degrees and 105 degrees. Alright, so properties of triangles. Here's what I want you to notice on this one. We name our angles the capital letters, and the side lengths are the lowercase of those letters. The opposite side though. Okay? So opposite of big angle A is our side length little a. Opposite our big angle B is our side length of lowercase b. And same thing for C. The most important thing that you can see on this page is that on all triangles, all three of the angles add up to be 180 degrees. Alright, so it says here, the measure of two angles of a triangle are 55 and 82. Find the measure of the third angle. So I'm going to let x equal my third angle. That's the angle symbol, by the way. So then I have 55 plus 82 plus x equals 180. Remember, angles on a triangle, all of them add up to be 180 degrees. So I've got 55 plus 82, so that's 137, plus x equals 180, and I'm going to subtract 137 from both sides. X is equal to 43 degrees. Okay, so a right triangle is a very special triangle. It only has one 90-degree angle in it. The other two are less than 90. Or, if you want to think about it this way, this is 90, so this plus this have to add up to be 90. Because remember, all three of them together add up to be 180 degrees. Alright, so it says here one angle of a right triangle measures 28 degrees. What is the measure of the third angle? So we're going to let x equal the measure of the angle. So I've got 90, which is one of my angles because of this word right here, plus 28 plus x equals 180. 90 plus 28 is 118, and I'm going to subtract 118 from both sides. And I get 62 degrees. Okay, on this problem it says the measure of one angle of a right triangle is 20 degrees more than the measure of the smallest angle. Find the measure of all three angles. So I know that one of them has to be 90. It says here, right triangle. I'm going to let x equal one of my angles, and I'm going to be, let's see here, 20 degrees more than the smallest, so x plus 20 is my second angle. Okay, so it says here that their sum is, doesn't really say it, but it's implied because it's a triangle, is 180. So I'm going to combine my like terms. Subtract 110 from both sides. Divide by 2. X is equal to 35 degrees. Now I find my next angle by adding 20 to that. So 35 plus 20 is 55. So my two angle measures are 35 degrees and 55 degrees. Okay, so you might want to read through this page. The key word here is similar figures. So if they have the exact same shape but different sizes, we say that they're similar. And the thing about similar triangles is that their angles are proportional. Well, their angles are equal, and their side lengths are proportional. Okay, so in this case, y is equal to b. That angle measure is equal. A is equal to x, z is equal to c, but their side lengths, if you'll notice, this triangle right here is 4 times larger than the smaller triangle. Every single side length is 4 times larger. Alright, so now let's take a look at this one. It says here triangle ABC and triangle XYZ are similar. The lengths of 2 sides of each triangle are shown. Find the lengths of the third side of each triangle. Okay, so here's one thing I want you to realize. The way this is written and the way this is written, this implies that A and X are equal to each other. B and Y are equal to each other, and C and Z are equal to each other. That's angle measures, not side lengths. Okay? So that means that our side lengths for the corresponding sides are going to be proportional to each other. So check this out. This side right here is proportional to this side right here. So I've got A is to 4.5 as, and then you can just pick whichever side you want. And I'm going to pick this one. So I've got 4 is to 3. Now this is a proportion, and how do you solve proportions? You cross multiply. So I've got 3A is equal to 4.5 times 4, and I get 18. Divide by 3, whoops. A is equal to 6. Okay, so now I want to find what y is. I don't know what little y is, so I'm going to set up another proportion. So y is to 3.2 as, let's do 3 is to 4. Cross multiply. 3.2 times 3 is 9.6. Divide by 4. Y is equal to 2.4. And that makes sense because we knew that it had to be smaller than 3.2. Alright, so whenever we use the Pythagorean Theorem only works on right triangles. It does not work on any other kind of triangle. Only triangles that have a right angle in it. The most important thing that you realize with this is that the 2 legs make up your right angle. Your hypotenuse is always opposite your right angle. And by the way, your hypotenuse is always the longest side of a right triangle. Alright, so we have this great little theorem called the Pythagorean Theorem, and this says that your 2 legs, the sum of your 2 legs squared, or your 2 legs squared then added together, is equal to the square of the third side, the hypotenuse. Alright, so check this out. Remember, your 2 legs, we have to square them both. 3 squared plus 4 squared is equal to, we're just going to call this sucker C over here, C squared. So I've got 9 plus 16 is equal to C squared. 25 is equal to C squared. What number times itself gives you 25? 5. 5 times 5 is 25. So therefore, this side is 5. Alright, on this one, we aren't given one of the legs. We're going to call that thing A over there. So I've got A squared plus 5 squared equals 13 squared. a squared plus 25 equals 169. Subtract 25 from both sides. 169 minus 25 is 144. What number times itself twice would give you 144? 12. So A is 12. Alright, on this problem right here, Kelvin is building a gazebo and wants to brace each corner by placing a 10-inch wooden bracket diagonally as shown. How far below the corner should he fasten the bracket if he wants the distances from the corner to each end of the bracket to be equal? Approximate to the nearest tenth of an inch. Okay, so that means this side is going to be x as well. So that's x and that's x. So our two legs are x's. This is honestly a little bit beyond this class because it's got some algebra in here that really I have not taught you yet. So if you just kind of look through this and kind of understand, I'm happy with that. A couple of classes down the road, if you want to come back and take a look, you'll know exactly what I'm talking about. X squared plus x squared is 2x squared. 10 squared is 100. You would divide both sides by 2. So x squared is equal to 50. Now, this is the part that I haven't taught you yet. In order to get x, you have to take the square root of both sides. So on my calculator, because honestly I can't come up with this in my head either, I'm going to type in the square root of 50 and I'm going to approximate it to the nearest tenth of an inch, which means that x is approximately 7.1 inches. Alright, that's it. We're done. So if you have any questions, let me know.